Alright, welcome to a video on multiplying polynomials and factoring, which is section 11.2 for Math 2. Okay, so this is going to go in your notebook on page 51. So first we're going to look at specifically multiplying a monomial by a polynomial. So a monomial by a polynomial. So really what this is just a fancy version of distribution. So let's do a little review what the distributive property says. So the distributive property is basically multiplying something, say A, times more than one term, B plus C. And so we take this A and we multiply it times the B, and then we distribute it and multiply it times the C as well, and then we add what we have. So we're going to get A times B plus A times C. Now this could be extended for more than just two terms. It could be extended for three terms. So that's essentially what we're going to be doing, but it's going to be with more complicated things other than just a number. We're going to introduce more variables, okay? So let's look at a very simple example. Let's say we have 2x, which is a monomial, times 3x plus 1, which is a binomial. And we're going to take the 2x and multiply it times the 3x and multiply it times the 1. So we are distributing. And so what we would get is 2x times 3x plus 2x times 1. All right, now I'm writing it out very clearly, but you could probably skip it if you feel comfortable doing so and just figure out what those things equal immediately. Such as 2x times 3x would be, well, 2 times 3 is 6, and then we're going to do x times x, where we are going to add the exponents, and so we get 6x squared plus, and then 2x times 1 is just 2x, and there's your answer. All right. So we can do that for a monomial times a binomial, or we can make it more complicated. So we're going to do an example 2, where we're going to take something a little bit more complicated, such as a 3x squared, which is still a monomial, times something like a trinomial, such as 2x squared minus 5x plus 4. So we're still distributing. We're going to take this 3x squared and multiply it by the 2x squared, then by the negative 5x, and then last by the 4. It gets distributed to everything in the parentheses. So that would look like a 3x squared times 2x squared minus 3x squared times a 5x, and then a 3x squared times a 4. Notice with the subtraction sign that we had here, I just put it right there. Those subtraction signs could cancel if you're distributing something with a negative sign, so just keep that in mind. All right, so again, when you're multiplying something like 3x squared times 2x squared, you multiply the 3 and the 2, which gives us 6. And then we multiply the x squared times the x squared, and in that case we're adding our exponents. And so we would get x to the 4th. And so that's the first term. And then I'm going to bring down the subtraction sign, and then we have 3 times 5, which is 15. X squared times x, we add the exponent, so that's x cubed, plus 3 times 4 is 12 times x squared. All right, make sure everything is in standard form when you're done, so from highest order, highest degree on down. Okay? So I do want to show you how to do this backwards now. Okay? And that's where we get into the factoring part of it. All right, so this is multiplying a monomial by a polynomial. So then now what we're going to do is we're going to kind of reverse that. So the second part of this is factoring out a greatest common factor. And this is going to be the reverse of what we just did. So this is the first kind of factoring you're going to learn. And we're going to learn about many other types of factoring. But this type of factoring is the thing that you always have to check for, and so it's really good that you see it first. Okay? All right. So we're going to first, we do a little review, and that is you need to recall what a GCF is. Okay? A GCF, or a greatest common factor, so a GCF, is the largest factor that goes into, so goes into evenly, all of the given numbers or terms. All of the given terms. More likely you can think of it as numbers, but we're going to be doing it more with terms because we're going to do variables now. Okay, so for example, you probably did this a long time ago. Let's take the numbers 18 and 24. So the greatest part of greatest common factor confuses people in that they think it needs to be bigger than 18 and 24, but it's actually smaller. Okay, so what you're going to do is think of all the factors of 18 and all the factors of 24 and see which one do they have in common. That's the largest one they have in common. So you could make a list. Factors of 18 are, well, 1 goes into everything, so I'm not going to include 1, but 2 goes into it, 3, we have 6, 9, and 18. So these are all the factors of 18. 24 also has 2, 3, 4, 6, 8, 12, and 24. These are all things that go into 24. And so if you look at which factors do they have in common, they have 2 in common, they have 3 in common, and they also have 6 in common. And so the greatest of the common factors would be 6. So the GCF of 18 and 24 is 6. Okay, so that's the basic thing that we're going to be doing. All right, so let's look at a problem that we're going to be doing. It's example 3. Let's do something like 3x to the 4th power minus 9x squared minus 12x. So there's sort of a two-step process to this. The first step is you want to look at the numbers. We've got 3, a negative 9, and a negative 12. You can ignore the negatives right now. But what would be the greatest common factor, the largest number that goes into 3, 9, and 12? That's 3. So that's the first part. So we know we're going to find the, so let's just talk about finding the GCF. Okay, so it's 3, but now we have to look at the variables. So x to the 4th, x squared, and x are our variables. If you think of them as what is the thing that they have in common, it's really about the lowest exponent that you have, which in our case is this 1. This guy's got x to the 4th power, which means he has x times x times x times x. This one has x squared, and this one has just 1x. So they all have at least 1x. Okay, I can't take more because this one only has 1. So the second part of our GCF is going to be the variable with the lowest exponent. And remember, if you see a constant term, the exponent that he has is 0. So that would be the lowest. We'll look at an example of that. All right, so part of your homework is going to be finding the GCF. The second part of it is going to be factoring it out. Okay, so factoring, I'll write this here. Factoring is the reverse of multiplying when it comes to polynomials. It's not exactly dividing. I think of it more, in this case, it's like undistributing, writing it the way it was before it got multiplied in. Okay? So how we're going to do that is we take the 3x, that is our GCF, and that is the monomial on the outside of your parentheses. Okay? Think of it like you're undistributing the 3x. So you have to think backwards and think about it as, okay, 3x times what gives me 3x to the fourth minus 9x squared plus or minus 12x. So we need to think about what has to be here. Well, if there's 3 terms here, there's going to be 3 terms in here. The number of terms is never going to decrease. Okay, so we want to think of it as we're undistributing. Okay, so this is my thought process. I go, okay, 3x times something gave me 3x to the fourth. What would that be? Well, it doesn't need a 3, so it's almost like there's a 1. The 3 times the 1 would give me 3. Or I don't even need the 1, right? But I do need x's. I only have 1x. I need 3 more. So that's really an x cubed. All right, and then I repeat that process. Okay, so 3x times something else has to give me the second term, which is negative 9x squared. Well, first of all, it's negative, so I need a negative sign. I need to get a 9. So to get a 9 from a 3, I need to multiply it by another 3. And then I need an x squared, so I have 1x, I need 1 more x, and that would give me x squared. All right, in the last term, we just go through the same process. 3 times what gives us negative 12x? Well, I need a negative, and to get 12, I need to get 4. I need a 4 there. But when it comes to the x's, I don't need any more x's. I only have to have 1 in this term, and I get that when I have from this right here. So I don't need to add any more x's. And there's your answer. That's the factored form. Okay? All right. So on page 51 of your notebook, I'm going to give you some to try. And I want you to try these problems, pause the video, and then I'll go through them. Okay, so these are the 3 problems I want you to try. So go ahead and pause the video, copy them down, and when you're ready, unpause the video, and then we'll look at the answers. Okay, ready? Pause. Okay, here are the correct answers. Did you get them right? So for the first one, we do 7y times 2y squared would give you 14y cubed. And then 7y times a negative 1 would be a negative 7y. Next, we have negative 4b squared times 3b cubed would be negative 12b to the fifth. Remember, add the exponents. Negative 4b squared times 2b would be a negative 8b cubed. And then last, we have a positive 8. The negatives will cancel, b squared. All right, for the third one, our GCF, first of all, if you look at the 15, the 20, and the negative 10, 5 goes into all 3. Okay, so that's how I got the 5. And then I look at the exponents. I have x squared, x cubed, x squared, and x. The lowest exponent is a 1. So you take the x out. All right, that's it.